This instructional video is on 4-3 additional practice. In number 1, it says the scatter plot shows Leanna's elevation above sea level during a hike. The trend line passes through the points 30 and 1070 and 75 and 1680. If Leanna starts at 663 feet above sea level and maintains the same rate, how far above sea level will she be after 1 hour? So you can click on that image to view the graph as I have pulled up in this slide, but you can click on it to view in your own computer screen. And then we're going to answer the questions. What is the y-intercept? What is the slope? And then what is the equation? So the y-intercept is our starting point. And so it tells us in the word problem that she starts at 663 feet. This is helpful because on the graph, that is not at a good starting point. It's not exactly on the readable line. And so because it tells us she starts at 663 feet, we know that the y-intercept is 663 feet. Now for the slope, we have to take our ordered pairs and we're going to use the box method. So using the box method with 30 and 1070, with 75 and 1680, we find our pattern. To go from 30 to 75 is a value of 45. To go from 1070 to 1680 is a value of 610. We set up our answer as a fraction, y over x, so the 610 divided by the 45. And we end up with 13.5 repeating. Now, the directions tell us to round to 2 decimal places. So 13.555, 55 is our 2 decimal places. The next 5 tells us to round it up. And so 13.56 is going to be our slope. Thus, the equation for the trend line is y equals 1356x plus 663. Part B of the equation, it says after 1 hour, her altitude will be how many feet above sea level? So this is our graph is represented in minutes. And so if we're talking about 1 hour, we know that that would be 60 minutes. So when we use the equation y equals 13.56x plus 663, we are going to multiply by our 60 minutes, our 1 hour. 1356 times the 60 minutes gets us 813.6. We then add it to our starting point, 663, to get a total of 1476.6, which would be our final answer. She is 1476.6 feet above sea level. Number 2, it says the scatter plot shows the annual revenue for one airline. The equation of the trend line shown is y equals 0.4x plus 4.1, where x represents the number of years since 2000 and y represents the revenue in millions of dollars. What was the approximate difference between 2003 and 2007? Now, you don't even have to click on the graph to solve this problem. Because the equation is given to us in the word problem, we can solve the equation without looking at the graph. So for 2003, because again, it's years from 2000, we would multiply the 0.4 times 3, because it's 2003. 0.4 times 3 is 1.2. We add that to the 4.1 to get an answer of 5.3. We solve it again using the 2007, so the same equation, y equals 0.4x plus 4.1. But this time, we're going to multiply by the 7 because the year is 2007. 0.4 times 7 is 2.8. We add that to the 4.1 to get an answer of 6.9. The question asks us to spot the difference. The word difference means to subtract. So when we subtract the 6.9 and the 5.3 answers, we end up with a value of 1.6. It's approximately $1.6 million difference. For number 3, an Arctic cold front is moving through the area. It is 37 degrees Fahrenheit when the temperature begins to drop. The scatter plot suggests a linear relationship between the temperature and the number of hours since the cold front has arrived. Use the scatter plot to answer parts A through C. You do not have to use the scatter plot in this problem, as the majority of the information is given in the word problem itself. For part A, what does the rate of change or slope represent in this situation? So it tells us that what is changing is that the temperature and the number of hours since the cold front arrived. We know that the temperature is dropping, and so the slope describes the change in temperature for each hour after the cold front arrives. So we know that the temperature is dropping. We know that it is based on the number of hours since the cold front arrived. Just again, looking through our word problem to find our sentence. For part B, it's the same word problem, but this question asks, what is the y-intercept for the trend line and what does it represent? So the y-intercept is our starting point, and it tells us that it starts at 37 degrees Fahrenheit. So the y-intercept is 37 degrees, and that is when the temperature begins to drop. So for our answer choice, we're going to pick this one here that says the y-intercept is 37 and describes the temperature of the area when the cold front arrives. So before anything has happened, it is 37 degrees Fahrenheit. For part C, it's the same equation, the same word problem, and the same graph. Again, you can solve the problem without clicking on the graph using the information that we know. We know that the temperature is decreasing, meaning our answer should be negative. We also know that the initial value, or sometimes called the y-intercept, is our starting point at 37 degrees. So in the equation y equals mx plus b, we know we're going to have a negative number, x, and then the plus 37. Even though we don't know the slope, looking at our drop-down answer choices, there is only one answer choice that meets this criteria, which is y equals negative 3x plus 37.